All right, so these are the notes for 4.8. We're going to look at the contributors to climate, and specifically, this one talks about geography. We've already talked about several things that contribute to a location's climate, meaning its temperature and precipitation patterns. So the first three we've already looked at. There are 5 major influences, and we've covered 3 so far. Earth's tilt, which we know affects the directness of the light that's actually getting to you and how concentrated the heat energy is going to be. Atmospheric convection currents, which are those Hadley-Farrell and polar cells. Earth rotation, which causes the Coriolis effect, those variations in speed of a location as the Earth rotates on its axis. And these next 2 are the new ones, ocean currents and geography, and we'll talk about each one of those and why it contributes to climate. The reason that we study this, the reason that it's important to understand the climate of a given place is because the organisms in that region are adapted to a specific climate. They evolved with these conditions. And so if we have changes in these due to any kind of variation in these climate contributors, you're going to look at some potential consequences for the structure and function of that ecosystem. If you take out some of the living pieces because the abiotic conditions have changed, all of a sudden your biotic community changes as well. Okay, so geography and how it affects your climate. There are a couple of features that are going to be the primary geographic characteristics that are going to affect your temperature and precipitation patterns. Those are going to be mountains and oceans. Mountains because they physically block the movement of air and cause air to have to go up and over them, which changes if it has specific temperatures and if it's holding water. And oceans. Oceans moderate temperature. Water has a really high specific heat, meaning it can absorb a lot of energy before it actually changes temperature. And when that water moves with the ocean currents, that heat moves with the water. So if you are close to the coast, that ocean is going to act kind of like a moderator of your climate. It's going to be more mild. You won't have as extreme heat or as extreme cold. For example, in Calgary and in London, they have almost the same latitude, so it's not distance from the equator. They're getting almost the same solar insolation. It's just their location in proximity to the ocean. So if we're looking at those, one of those is going to have a warmer average temperature in December. Now, it's important to note that both of these are in the northern hemisphere, so December is going to be in the winter because that tilt is away from the sun in the northern hemisphere at that time. So in the winter in London, it's a lot more temperate than it is in Calgary. Calgary is not next to the ocean, and so it's going to experience not going to experience that kind of cushioning and that padding of the ocean, keeping its temperature more middle ground, more moderate. And so our high temperature on average in Calgary in that time is 29 and the low is 10 degrees versus that same time period, same latitude, London is about 20 degrees warmer than that. Mountains cause what are called rain shadows. What you want to think of with the rain shadow is when you have a shadow, you are blocking the light from getting behind you. Mountains are going to do the same thing with rain. So rain shadow is a mountain's tendency to block the area behind it from getting rain. The reason this happens is because as you have water-filled air that's coming over the coast, over some body of water, the air is going to be warmer because the ocean is moderating the temperature, and it's going to be pretty humid because that air is going to have water that has evaporated into it. So that water in the air is going to get carried up to the land. This is what's called your prevailing winds. It's coming towards you. Those prevailing winds come into the coast, they hit the mountains, and now they have nowhere to go. They can only go up. We know from the Hadley cells when air goes up, it cools down because of adiabatic cooling. And when that happens, it drops all of the precipitation. So all of the water that it was holding, that evaporated ocean water, now can't be held in that air anymore, and so it's going to fall. So this side of the mountain, where the wind from the warm body of water is coming in, is going to experience lots and lots of rain. But as the air comes down on the other side, now it's going to experience adiabatic heating, where the pressure pushes that air together, it gets hotter, and it's dry. So we tend to have very arid conditions on the backside of the mountains. Okay, so in bullet point in terms that you could write down if you didn't get all of that from me just saying it. Warm air from the ocean that's holding water hits what's called the windward side. So the side of the mountain that the wind is hitting is the windward side. It goes up, it cools, drops its water, and you get rain. Rain is good for growing things. So you get lots of vegetation, you get very forested kind of areas there. As it comes down, we call the area on the other side of the mountain the leeward side. So windward, wind is coming in, hitting the mountain. Leeward is the backside where it's coming down. We see this in places like South America. We also see this in our coast in the Pacific Northwest, the Cascades and the mountain range that's on the Pacific coast. You have really forested green areas on the windward side, and on the leeward side where the air is coming down and is really dry, you have very arid conditions. So I'd like you to try to figure out, in this scenario, this geography in South America, which side would have arid desert conditions of the Andes? Would it be the coast next to the Pacific or the side nearer to Brazil? Wind directions are shown in the picture on the left. You have wind coming from the Atlantic going this direction. The wind from over here kind of gets deflected. It doesn't really go past the mountains. I'll give you a sec to figure that out. All right. If you said the side near Brazil, you'd be correct. That is because the eastern trade winds, and winds are named for where they're coming from. So eastern trade winds are the ones coming from the east side, blow the air from the Atlantic across South America. It's a far distance, so the distance between the coast and the Andes Mountains is pretty far, but you still see this effect, and it's pretty exaggerated. You can think about this too because of the geographic features that we know about. On the Brazil side, on the eastern side, you have the Amazon rainforest. On the other side of the Andes Mountains, you have the Atacama Desert. So you have the windward side where the wind is coming from, hitting the mountains. This side here is very wet, and the other side is very dry. East side of the Andes gets the rain, west side gets the dry air. The other thing that contributes to this Atacama Desert being on the western side, is its latitude. It's about 30 degrees south of the equator, and we know that is where our Hadley cells are coming down. So we have this double whammy of it's on the leeward side, and you have the 30 degrees latitude that is going to make your desert extreme. We can see this if we look at a satellite image. You have very, very brown on the leeward side near the Pacific Ocean, and you have very, very green on the other side. Ta-da! There's that. And there's our exaggerated 30 degrees south of the equator that has that to the extreme. Okay, and that's it. That's all your notes. If you have questions, ask me when you come back to class. When I see you next time, we will go over any questions that you have. Your next thing is going to be to do the topic questions for this section, and I believe for 4.5 as well, or whatever it is. Check the week at a glance. Do that. Okay, see you soon.